Hi guys, this is Peter Ryan here from Dundalk Institute of Technology. Hopefully at this stage you'll already have got your eezybotarm kits, okay, so that you can assemble your own robot arm, and there'll be separate videos on those assemblies, and there'll be other videos on writing the programs and setting up the electronics so that you can control the robot arms. And there is a video unboxing. There is an unboxing video where I go through everything that should be in your kit. Okay. So the first thing we want to do is to introduce you to where we got the eezybot arm. Okay, in the first place. So if you open up Google and go to Thingiverse. Okay, I have to click on it first, I guess. I'll just Google Thingiverse. Okay. And that will open up this site for you. So Thingiverse is a community sharing site, right, where a lot of makers from all around the world upload their designs and the things that they have made, okay, in a format where other people can download them then and print them themselves. And some of the contributors give full instructions on how to make the kit, and that allows other users then to make them and possibly do some improvements. Okay, and a lot of users allow people to actually upload the improvements to their original design. So that means that over the years, designs can get very good and very detailed. So one of the designs on this is the eezybot arm. So we'll just search for that. And you can go to this website and search for the robot arms if you want. Obviously, we've already printed them for you, so you don't need to, but you could if you wanted to. And you're going to see a lot of different versions that pop up. Okay, so the one over here on the left is the first version, okay, uploaded by a user. I think his name is DkIT on Thingiverse. Okay. The Mark II then is his second design, so it's a bigger version. It's almost twice the size. Okay, so it uses much more powerful motors. And the third design then is back to the original size, so similar to the one you have, just with different motors. And it has a little bit more range in some of the movements. Okay, so we could have printed that one, okay, but it's just a little bit more involved in the printing. So as a first introductory exercise, we decided to go with this one, which is more simplistic, okay, and easier to print because we had to print about 30 of these. Okay, so we'll click into that. Okay, so that's the user. So this is the eezybot arm. Okay, so this robot arm has a servo in here, a servo motor, which is a motor with built-in gearing system to slow it down. Okay, so that this robot arm can rotate then between angles. So I think it's 0 degrees to 180. Okay, so it has that much rotation. It has another arm here which controls this link, which lets up and down this arm. Okay, and there's another servo here at the back that moves this vertical arm forward and backwards. Okay, and then your one last servo motor is up here on the gripper, and that's just for closing the gripper or the claw to pick up items and drop them again. So this is more for demonstration and education. It's not going to pick up very heavy items, right? So these motors are not powerful. Okay, so it'll pick up little blocks of foam. Once you make yours, if you have little blocks of foam or light plastic or cardboard, it will pick them up. As long as they're not too small that it can't grip them, or too big that it can't grip them as well. But if it's relatively small and light, it will pick them up. Okay, so this robot arm is actually based on a real robot arm, believe it or not. So there is a robot arm. I think it's an ABB machine, so a palletizing robot. And it works in a very similar way to this. So it has the two motors down here to control these arms. It has a gripper mechanism up here. And it has the rotary motor down here for rotating it. So the user based his design on the movements of that machine. So this is a nice little design to do for education purposes because it does represent a real robot that's in industry. Okay, So we can just go down to the thingy files here, and there are 17 printed files in total. So we can download each one individually, or you can download them all. So for this video, to save time, I'm just going to download the basement part here. Okay, so that will just download as a file. It won't be in a zip folder or anything. If you do download all of them together, they'll be in a zip folder, and you'll just have to unzip them or uncompress them. Okay. But for us, just one is fine. Okay, and we can just go open that file. Okay, so that's my part, right? And that's you should recognize that. That's the base of the robot arms that you have. Okay, so again, we didn't design these. These are from that contributor on Thingiverse. Okay, and they're free to use for non-commercial purposes. So let's have a look at some settings on this. Again, I don't need to change anything on the orientation. All of that is perfect. I'm not going to change the scale. Right, I have my Ultimaker green PLA, right, and my Ultimaker 3 extended set. Okay, so let's click up here and have a look at some of the other settings. So the first one to look at is my quality, and I have my layer height set to 0.2 of millimeter, which is fine. I don't need that any finer. I won't go any coarser. Okay, so 0.2 is fine. My initial layer height is 0.27, so that's set a little bit higher, and that's just to help it stick to the bed of the printer. Okay. So my line width is 0.35. Right, there's a few of these. These are all 0.35. The actual extruder is 0.4, but if you make these size a little bit smaller, it just increases the quality a little bit. So we won't look at anything else there for now. Okay. The shell, right? There are some things in here that are important. One is the wall line count. So if we set this to preview, I have to slice first. Okay, so that's telling me it's taken 2 hours 53 minutes, which isn't too bad. But let's just bring down this to the middle layer, right? So in here you should see that we have 1, 2, 3 lines here along the wall. So the printer passes 3 times along this wall, 3 times along this wall, and the same on all the others. So that wall line count comes from here. And we could change that to 2. And then we'll have to hit slice again. Okay, and we've changed from 2 hours 53 to 2 hours 33. So we've saved 20 minutes. But we have made our part, a little bit weaker. Okay. So you would need to be conscious that these kind of changes might save time and material, but they'll also change the strength of your material, obviously. Okay, so you need to think about what your part is doing. So because this is the base and these robot arms will be probably made and unmade a few different times, I've kept it at 3, right? Especially for these kind of parts where they could snap off if they were weak, right? So it's important in this case just to have that 3 walls. Okay. The other thing you can set is the number of bottom surfaces. So down here, the number of solid layers that we have on the bottom before it gets into this meshed infill. So that's usually here. So top layers is there and bottom layers is there. So I have bottom set to 5 and top is also set to 5. Okay. We could probably get away with 3 at the bottom. Again, we'll make our part a little bit weaker by doing that, but we are saving a bit of time. But I won't reduce my top. Okay, so up here at the top and the top of all the other surfaces, right? If I reduce that too low, what will happen is, again, I'll be printing over these mesh surfaces. So what will happen is you'll end up with gaps and bumps in the top surface. So it takes a few layers at the top to get a good surface. So we won't reduce the top down. We'll leave the top at 5, but we might change the bottom to 3. Sorry, I should have changed that. Yeah, so you're only talking about 10 minutes. So it's not making that much difference, But I suppose if you were printing lots of these, you'd save material and save time. Okay. The other thing we need to look at here is the bottom layer. So the bottom layer here, I have a brim on at the moment. So let's look at that. Okay, so build plate adhesion is where we'll find that. And we have brim turned on. So let's turn off brim, right? So let's turn off that and put nothing on there and just see this. Okay, so that is now the bottom layer that my printer will print. And what you should see is that these here are quite thin and you have a feature here that is quite thin. So if I look at the way that's going to print, okay, it's going to print the holes first, right? That's a setting that I have turned on. Okay, so now it's printing some of the other features. Okay. So I'll speed it up a little bit. Okay, so this is the bit I wanted to show you. So as I've printed this in one go here, right, and I've now continued to print along, because I don't have the brim, right, what may happen here is that these corners might lift a little, right? There's very little surface area holding that on at the moment. That's only 0.4 of a mil thick. So as it's going around, what may well happen is this first layer may not stick particularly well in these kind of geometries. Okay, anywhere where you have thin pieces of material like that. Okay, so, and ends where it stops like that. So by turning on the brim, we create more parts here. So if we go and we turn on the brim and press slice, so now what it does, oh yeah, okay, sorry, that's the second layer. I was thinking of something wrong. So the first layer, it's going to print the brim first. Okay, so prints all of this. Okay, now it prints the brim on the inside. We could turn that off if we wanted to. Okay, so now it's going to start printing the holes and all of the other features. By the time it actually gets to print that feature we looked at a second ago, which is there, right? It's now going to print the outside of the part. That's sticking now to the brim that's already on, right? So that stops that first layer of the actual part, that first corner of the actual part lifting, okay? Because the brim has already set onto the bed and it holds down those layers. So by the time my first layer is actually printed, okay, it will look like that. Okay, so rather than just having these sharp corners, they're now part of a larger sheet of material that holds that down. And when we allow on our second or third layer, okay, you will see that that's much less likely to fail, right? So at the end, you will have this brim of material here, right? So you would need to go along and just cut or peel off that layer. That layer is only 0.27 of a millimeter thick, so you'll have no problem taking that off, right? So, you might need a knife or scissors, but generally it'll peel off, okay? So it might affect the quality of your finish here. You might need to just sand the edges or that, but it makes the bed adhesion much better, and you'll have a much better chance of this printing successfully rather than failing. If you print them without it, you're going to find that in particular along this part here, this little notch here for the wire will probably lift. And you'll probably see that on some of the prints that you have in front of you. Right, this little feature here will have came loose and will have warped up here. Right, so some of you might see that. That's what has caused that. They were printed without a brim, probably by me, and didn't have good adhesion there on that. Okay, for this it wouldn't matter, but if that was an outside feature where it was seen and you were printing more on top of it, it could eventually cause, it could ruin the look of the part, but it could also cause the part to come loose. Okay, so that's that part, right? And again, if I want to send that to the printer, all I have to do is press save to file and call it whatever I want to call it, base part, or, you know, again, Ultimaker 3. So that's important. It tells me what printer, and then this tells me what part. So again, if I create this file from my Ultimaker, I can't put that onto my Anycubic, right? So they're not compatible. Okay. So if you do have access to a 3D printer, hopefully you'll have an introduction to some of the things that you might set. There are lots of other settings in here, right? The more experience you get, the more of these you can alter, okay? But generally for the printers, they come with, in here, they come with a profile. So with the different thicknesses, okay, and different settings in here. So we went for the fast one. We could go for the normal, which would be 0.15 millimeters. Different printers will have different profiles, okay? You can create your own profile. So if you get a group of settings that work for your printer, you can then just create that from your current settings, and rather than having to change it every time. Okay, but the better a printer you have, I guess, if you have a printer like an Ultimaker, the predefined profiles work very well, so you may not have to make much changes. Okay. Again, when I selected the green material here, that would have selected green PLA, would have changed this temperature here, right? So if I've bought my material from Ultimaker, then that temperature will be fine. If I have bought cheaper material from somebody else, from a different manufacturer, I may need to change the temperatures, right? So this is the temperature of the extruder, right? The material, and this is the temperature of the bed, right? So this bed is heated to help it stick, okay? So you may need to change those to match the material, but other than that, you probably won't need to change anything. Okay, so that's a quick, hopefully, introduction to the process of setting up a slice file, so in Cura for your 3D printer. Hopefully I haven't confused you too much, and you've picked up a few insights into the 3D printing process. Okay, so there will be other videos on the later steps, but for now, thanks very much.